Hi, my name is Matt Bevel, and I'm the Deputy Chief Engineer for the Space Launch System, also known as SLS. And I want to thank you guys for participating in this year's student launch. And congratulations on completing the program. Hey, I know what it takes to do this type of work, from writing proposals, attending reviews, building test hardware, conducting the tests, going over the data. We've all done that, and I really congratulate you on completing that. And I know it takes a lot to be able to get a rocket to the launch pad. Speaking of launch pads, we currently have all of the SLS hardware at the Kennedy Space Center preparing for its first launch. And this is going to be a critical step in the future of human exploration. And that's where you guys come in. We're going to need your skills and expertise to carry on this dream for the future and keep this program viable. So to salute your success in your launches, SLS Chief Engineer John Blevins and I are going to launch our own SLS rocket. John, are you ready?
I sure am, Matt. Again, congratulations to all of you for completing the student launch this year. I'm sorry that we can't see all of the launches in person. I sure wish we could, and I look forward to it next year. But until then, and until the real SLS flies, let's light this candle.
3, 2, 1.
Hi everyone, I'm Bill Nelson, the Administrator of NASA. Welcome to the 2021 NASA Student Launch Virtual Award Ceremony. It's programs like NASA's Student Launch. These are part of NASA's greater STEM effort, and it prepares a new generation of scientists, engineers, astronauts, and explorers. I hope you're as proud of what you've accomplished and learned, and I encourage each of you to maintain a curiosity to learn and to explore. This year's challenge will hopefully serve as an inspiration for a lifetime of learning. And that is because someday it may be you designing a new spaceflight system or a spacecraft, or even a vehicle to land on another planet. How about a spacesuit to keep humans alive on Mars or destinations beyond? Every year, teams like yours work diligently, and they stand up against all incredible obstacles to succeed in the NASA Student Launch Competition. This season wasn't easy. It wasn't normal. But you all succeeded despite the challenges. So congratulations to all of you for seeing this mission to completion.
Good afternoon. Welcome to the 2021 NASA Student Launch Virtual Awards Ceremony. On behalf of the Marshall Space Flight Center, I want to congratulate all of the teams who participated in this year's event. The 2021 student launch season has been an incredible display of engineering, science, and tenacity. I want to start off by saying thank you to all of the sponsors and the NASA Student Launch Management Team for doing all it takes to see that this event happens. Your contribution and hard work build and test complex rockets and scientific payloads, and for that you should be proud. At Marshall Space Flight Center, we work to design and build the Space Launch System and the Human Landing System, and we also lead the way for NASA's Artemis program. But those programs require teamwork from all NASA centers across the nation. As one of the Artemis student challenges, this activity is closely aligned with how we actually approach the Artemis program. I know it takes an entire team to design your student launch rockets and your scientific payload, and you should all be proud to have such dedicated friends and classmates to help you reach your goals. A whole mission can be very complex, but by focusing your efforts, you've learned the power of how to succeed as a group, as a team, a real team. At Marshall, our teams do the very same thing, working together to make the greater whole succeed. Engineering, propulsion, testing, fabrication, safety, finances, and many others work along each other to accomplish our goals. Someday, I hope to see some of you joining our NASA team. This season, you are tasked with developing a lander system in addition to your rocket, a very unique and difficult challenge. Just an example of how this competition mirrors our own current NASA missions, like building this human landing system to safely land astronauts on the moon. The student launch competition and all of our Artemis student challenges are critical for our own mission. I encourage each of you not to lose the sense of purpose that led you to the launch field. The lessons you have learned are a first step to being part of our nation's space exploration program. You are the scientists, the engineers, the technical writers, and the architects of tomorrow, and we will rely on you to continue. On behalf of the NASA Marshall Space Flight Center, I congratulate each one of you on your hard work and perseverance through this process. Appreciate every moment when everything worked as planned and learn from those times when they did not. Support each and every member of your team. Most importantly, never lose a sense of curiosity that leads you to ask the what if question. And finally, I want to wish all of you success in your endeavors beyond the student launch competition. Your educations, your careers, and your personal lives will forever be affected by it. Work hard, have some fun along the way, and find a profession that you can truly enjoy. Congratulations on your hard work and success, and thank you for being a part of this program.
Well, thank you, and good afternoon, everyone. All of you involved in the student launch competition with NASA. I'm really delighted to join you today. We at Northrop have been involved in student launch competitions as a sponsor for many years. One of my personal most favorite things to do with the folks at the Marshall Space Flight Center. I want to also start off by congratulating Senator Nelson on his appointment as NASA Administrator, and I think it shows great attention to the importance of the student launch competition and the future of our graduating college and high school students, that the administrator would take the time to speak to us. So thank you, Senator Nelson, and we appreciate your support for all we're doing in space exploration. I've spoken to the group before on the awards day, and I really look forward to hearing who the winners are here shortly. And congratulations on a great effort. I've personally witnessed a lot of the projects in the past and have been awe-inspired by the work that you all do at the levels of college and high school and even younger. It's really great to see the enthusiasm around rocketry and what we can do with space exploration. So thank you for your interest and your passion for what we do. I have a presentation for you. I like to call this a funny thing happened on the way to the space station. What I'm going to do here is share with you some of my experiences, but I want to prompt from mine the things that could happen to you in your experience going forward as you join your careers. And I call it a funny thing that happened on the way to the space station because it doesn't end up like you might think. Even though I was selected to be an NASA astronaut, there were a lot of things that transpired that I wouldn't have expected. And that's something you should anticipate too in your careers. You will enjoy a lot of the things that my generation prepared for your generation. And, the future of exploration with the Space Launch System, the Orion capsule, going back to the moon, onto Mars, it's all available for your generation. I'm really even envious of you to be starting your careers with such an exciting future. So if we go ahead and kick this off, I have a photograph that I like to put into context most of my career. I went to the Air Force Academy and pursued a degree in aeronautical engineering, and then went on to fly F-15s. And in the top of the picture there, you see an F-15 on the wing of what was in the day a Russian Bear bomber. And just in the inset below that is a photo I took of the tail gunner, because I had to intercept those bombers over the North Sea when I was stationed in Germany many times, and fly right up on the tail of that aircraft. And over on the left is a Flogger, a MiG-23, that was also on the east side of the German border at the time, back in the days of the Soviet Union and the Cold War. I flew F-15s in Germany to protect the western German border from the east, and would often see airplanes like that in the sky. Well, lo and behold, one of the pilots in that airplane was an individual that became a very good friend, Vasily Tsibliev. He became eventually the chief of the Cosmonaut Corps when I was the chief of the Astronaut Corps at NASA in Houston. And that picture in the lower center is a handshake between Vasily and I when I got to dock the space shuttle Atlantis with the Mir after they had had a fire and a collision of a vehicle on board. That was a very, very strenuous time for the cosmonauts, and it was just a very tight partnership that we had with them. And it was just kind of a miracle for me to imagine that, having grown up in the Cold War, one of the funny things of this story is that we actually saw the Cold War end, and that we were collaborating with pilots and cosmonauts who were once considered our enemies. So you just never know where, as they say, life's a box of chocolates, where the road's going to take you. But what an exciting thing for me to have been a part of. In this next photograph here, this is the space shuttle as it sat on the launch pad. The vehicle weighs somewhere near 5 million pounds, but produces nearly 7 million pounds of thrust. By comparison, the future SLS vehicle will be 7 million pounds, producing 9 million pounds of thrust. So it's an immense amount of energy and a lot of capability. In the next photograph is one of my launches, the 4 that I was privileged to be a part of when I was the commander of STS-84, a very international crew. Eileen Collins was the pilot. I was the commander, and we have a Russian woman on the crew, an American astronaut of British descent, a French astronaut, and an American astronaut of Chinese descent, and another American astronaut of Peruvian descent. So quite an international flavor in that crew, and this was the flight that we went to visit Vasily. His crew was already on board, and we were going to leave Mike Foale on board and bring Jerry Linenger home on that particular flight. This is our approach to the Mir space station. Today's International Space Station is immense by comparison, but this served as a test bed for us to build the International Space Station back in the 90s. And we finished 7 missions to go to the Mir. I was lucky enough to be on 3 of them. And this is a view of the Mir as we approached it for docking. This is a view that Vasily had as I approached for docking, where you could see just behind the forward bulkhead of the opened payload bay is a docking port, just behind the 2 windows on the roof of the forward cockpit area. That docking port, I am flying towards the Mir space station to connect, and that whole virtually that whole part of the flight is done manually with the crew on the flight deck flying the space shuttle up to the station. Once we're on board, we take pictures like this because we can. This was the very first docking with the Mir. There are 10 of us on board there, and what's neat to observe is how we all hold ourselves in position. Anatoly Solovyev in the purple shirt with his arms crossed has his feet under the handlebar on the right-hand side of the image. And everybody has themselves braced in some way so they don't drift off for the photograph. A lot of fun to do that kind of thing in zero gravity. One of the most interesting things about the Mir program was that it was a political agreement between the United States and Russia. And senior President Bush and at the time Russian President Yeltsin agreed to put an astronaut on Mir and to fly 2 cosmonauts on shuttle. And this was the crew of the first docking mission. Hoot Gibson was the commander and I was the pilot. We went to visit President Clinton after the mission and brought the cosmonauts with us to celebrate that first mission. We were funding part of the program so that we could collaborate to create the International Space Station with Russia. And it was very important to keep the Russian engineers from sharing secrets with the Irans and Libyas of the world. And we had a piece in the program that would have us collaborating instead of competing in the political world. So it was an important program to the president because of that reason. Later, as we went into the program with the Mir program, there had been issues with the stability of the systems on board the Mir, and virtually everything that you would not want to have happen to you, a depressurization, a fire broke out on board, a collision with an oncoming, unpiloted, uncrewed cargo ship, all happened to the Mir during these 7 flights. So in April '97, Commander Tsiblev attempted to remotely dock the Progress, but it had too much closure and he was unable to stop it, and it caused a collision. And so we were there to help with repairs and equipment, and to bring Mike Foll up to replace Jerry Linenger. This is a view of what that remotely piloted, uncrewed Progress ship would look like if you were sitting in the space station. That is like a robotic piloted vehicle, much like you might fly a drone today. The crew on board the space station was trying to fly it from the station to bring it in. It just had too much energy. This was a photograph we took during one of our shuttle flights where one was in proximity, and so you can see the detail of the vehicle there. During the collision event that happened, you can see in this next photograph, you can see how the vehicle actually came in and made contact with one of the solar arrays and then deflected off of another module and then veered off into space, and it punctured the vessel to where they were starting to lose atmospheric pressure. And the crew almost had to evacuate the space station. But they managed to seal off that leaking module from the rest of the station. And for the rest of the program, we attempted to help them recover from that failure and to bring that module back to life. Unfortunately, that module ended up being sealed for the duration of the program. Now, the reason I share these with you is that the good learning, these were, events that you would never want to have happen to you: a fire breaking out on board, a collision, a loss of pressurization. But because they happened and we were able to work around them and recover from them, we made the International Space Station design much more robust and much more capable of sustaining injury, if you will. And so the space station program has been successful for many years now based on the lessons we learned in this program. And part of what I'm telling you today as you go and become part of our new program in the future to go back to the moon and onto Mars is the lessons we've learned. You will inherit and take those lessons into your designs, into your operations, if you will, of our exploration program. So this was kind of a really great moment for me. It was after we got docked. My friend Vasily Tsiblev, later after this flight, he and I would become respectively the chief astronaut and the chief cosmonaut, and we worked together selecting crews to become the crews who would fly the early space station flights for the ISS. And this was after we docked. We had a dinner together with the crew, shared some photographs and some gifts, and it was just a great moment for all of us. And of course, with the space shuttle, it flies like a rocket. As it leaves the launch pad, it flies like a spaceship in space, and it doesn't really fly like an airplane until the last 2 or 3 minutes, when it's in the lower atmosphere and has a wing to put us down gently on the runway. Picture of my landing here at Kennedy Space Center. A great machine, one that we learned a lot from. So let me take you now into what we're doing in the future, and we are on the verge of launching the Space Launch System. We're privileged here at Northrop Grumman to be the provider of both the boosters and the launch abort system on the top of the Orion spacecraft. So here's a little update of what we're doing. We are returning to the moon, but we're returning to stay. I think of it as equivalent to establishing a station from which we can do research, much like McMurdo Station in Antarctica. and where we can send crews to the surface on a regular rotating basis to learn how to live on other worlds. That's a real challenge. The human element in our exploration is really the limiting factor. And so learning to live autonomously in harsh conditions far from home is a prerequisite for exploration. So here's some photos that kind of get into that human element. Apollo changed the world. Artemis will do the same, but this time the vision is different. We're going to stay. We're going to use the lessons of the past to enable us to stay. A little bit of a expanded view of the SLS rocket. I pointed to the boosters on the side. Those were derived from what we flew on shuttle, but they're 25% bigger. They're extended with an extra fifth segment. The core stage is like the core external tank of the space shuttle, but it also is stretched for more capacity and power. And instead of 3 engines that were in the tail of the shuttle, we now have 4 at the base of the core tank that you see in the middle there. And then, of course, you have the upper stage, an adapter for the Orion, and at the very top, the abort system, something we didn't have in shuttle. This is actually capable of removing the Orion from the launch vehicle if something were to go wrong, and move the crew away from that launch vehicle and return them under a parachute safely to Earth should there be an issue during launch. Great safety enhancement that really takes a lot of the lessons of the past and applies them well. And this kind of shows the various configurations that we plan to have through different blocks. Eventually, over on the, we'll fly here hopefully towards the end of this year. Our first configuration that will have an interim smaller upper stage with an Orion. We'll fly around the moon and without a crew to test out all the systems. And then the second flight will have crew on it. There's a cargo version of that. And then you can see in the middle, you've got the exploration upper stage, a bigger upper stage. And then finally, what they call in a later block down the road is more performance from enhanced propulsion systems. And so this vehicle has the capability to evolve to even bigger capabilities than the Saturn V had. So here's some valuable lunar science that we can conduct. A lot of people ask us, and I'm sure you get asked, that you're interested in rocketry, why do we do this kind of activity, and why take this initiative? So studying the planetary processes, records of the ancient sun, the fact that there's no atmosphere, a lot of what is deposited in the topsoil of the moon in the regolith gives us history of our own solar system, in particular the sun. Ability to study and have a better viewpoint from a telescope standpoint, out of the shade, in the shade, out of the view of the sunlight. There's lots of different research that can be done in the world of science on the surface of the moon. And the other thing is the mission will drive our designs. And when we were in low Earth, we only needed 3 hours to get home, and we had reached speeds of 17,500 miles an hour, only 250 miles above the surface. But look what happens when you go to the moon and then on to Mars. You have much more speed. You are 3 days instead of 3 hours away. You're 1,000 times further away. And then when you go to Mars, it gets even more daunting. 6,200 degrees temperatures on return, 9 months to get out and back, 39 million miles away. So quite the deal. Very challenging. So it's over to your generation. The booster stacking for the first mission is complete. You can see that here with the vehicle at the assembly building in Florida. And the next step is to move the core stage in between them. We've got some photos here of the testing that was done on the core stage and the shipment and arrival to the VAB in April. So all of that processing is underway. And you can see these pictures as we progress towards Artemis 2 now. A lot of the hardware that we need for that second flight has already been built. And so we expect to go from that flight with no crew to a flight with crew very quickly as we build into this next vehicle. And so it's over to your generation to inherit exploration systems, capabilities, vehicles, rockets, spaceships, and take us where we've never been before. I really want to congratulate you for I know how much work you've put into this. I've seen it year after year. I know your class is no different this year. I really look forward to hearing who the winners are and being inspired once again by the ingenuity of your projects. So thanks very much for having me, and look forward to seeing you in your careers in aerospace.
This year, perhaps more than any other before, social media has been the communication tool keeping NASA and its partners connected to the world. The story of the Artemis program, the Green Run hot fire test of the SLS rocket, the Mars lander Perseverance, and SpaceX Dragon docking with the International Space Station are just a few stories brought directly to NASA audiences through the many platforms available. This year's social media award winners brought their audiences along with them on their journeys. Pictures in the labs showed what it takes to build one of these high-powered rockets. Videos showed the multiple test teams must perform before finally heading to the launch pad and flying their hard work thousands of feet in the air. Traditions that transformed people into a team were shared, and the next generation of Rocketeers were educated and inspired along the way. For the Social Media Award, teams are judged on their posting consistency, their creativity, and their content. It is my honor to announce the top 3 teams in each division of the Social Media Award category. For the middle school and high school, or SLI division, finishing in 3rd place is Minster STEM Club from Minster, Ohio. Congratulations. In 2nd place is Oakton High School from Vienna, Virginia. Congratulations, Oakton. And in 1st place is Sylvania Northview High School in Sylvania, Ohio. Congratulations. And for the College and University, or USLI division, finishing in 3rd place is North Carolina State University in Raleigh, North Carolina. Congratulations to you all. And in 2nd place is the University of Puerto Rico, the Mayagüez campus from Mayagüez, Puerto Rico. Congratulations to you all. And in the number 1 spot in 1st place is Purdue University from West Lafayette, Indiana. Congratulations, Purdue. And congratulations to all the teams.
The challenge of designing, building, and flying a high-powered rocket was a big hurdle each of you had to overcome to be here. But a team's success is only part of what makes a team memorable. Your fans, parents, friends, and community sponsors, they're going to remember a team for their team spirit. Team spirit is the bond formed by team members who have put in so many hours together, even virtually. Team spirit is an important part of this competition, and we want to acknowledge the teams who work, compete, and celebrate with lots of enthusiasm. The Best Team Spirit Award is voted on and chosen by members of the competing teams. It's given to teams in both the middle high school division and the college university division. So this year's winners in the middle high school division, or SLI, are in 3rd place, Sylvania Northview High School, Sylvania, Ohio. In 2nd place, Madison West High School, Madison, Wisconsin. And finally, in 1st place, Harrison Central School District, Harrison, New York. This year's winners in the College University Division, or USLI Division, are In third place, University of Notre Dame, Indiana. In second place, California State Polytech University in Pomona, California. And in first place, Auburn University, Auburn, Alabama. Congratulations to all the winners.
A rocket that flies precisely to its destination performs its mission without delays or setbacks and can safely return to the ground are the objectives set forth by the NASA Student Launch Review Team. But those criteria aren't the only things that make a team's rocket memorable. A rocket with flair and a unique look will make it stand out amongst its competitors. Many teams have put countless hours into the look and design of their rockets, fueling their team spirit and adding interest and excitement at the launch field. The Best Looking Rocket Award is given to teams in both the middle high school division and the university college division. It is voted on by the competitors themselves. This year's team submitted pictures of their rockets for their competitors to view and decide who they thought produced the best looking rocket. The winners this year in the middle high school division for Best Looking Rocket are, in third place, Oakton High School, Vienna, Virginia. And in second place, St. Vincent St. Mary High School, Akron, Ohio. And finally, in first place, Sylvania Northview High School, Sylvania, Ohio. Moving on to the college university division winners, we have in third place, Vanderbilt University, Nashville, Tennessee. In second place for Best Looking Rocket, we have Kent State University, Kent, Ohio. And in first place for Best Looking Rocket, California State University, Long Beach, California. Congratulations to all 6 of these teams. Those are some great looking rockets.
When designing and developing a new technology or launch system, it is critical that engineers, scientists, and technicians possess the ability to innovate, to endure setbacks and difficulties, and to accurately complete the difficult work set before them. There is, however, another key skill required for the success and duration of a major program: communication. The Project Review Award recognizes the college or university team that was deemed to have the best combination of written reviews and formal presentations throughout the student launch year. So in the design division, the Project Review Award winner is New York University in New York, New York. In the launch division, we'll announce 3 places. In third place this year is Auburn University from Auburn, Alabama. In second place is Vanderbilt University of Nashville, Tennessee. And the winner of the award this year is California State University, Long Beach of Long Beach, California. These teams went above and beyond expectations when delivering their preliminary design, critical design, and flight readiness review, written reports, and presentations. Their reports clearly described how the program was evolving over the course of the project lifecycle and contained several unique features to aid in navigating the extensive documents. The team answered questions directly and honestly and humbly accepted constructive criticism and feedback. Congratulations.
first glance, student launch may appear to be all about building and flying rockets. But there's another equally important aspect: designing, building, and executing a scientific experiment. Rockets are the means to transport these scientific payloads to their destinations in the stars. A payload can be anything from a telescope to a satellite to a robotic lander that's destined for another planet. The payload component of this year's NASA student launch competition challenged teams to build a lander system that would be deployed from the rocket during descent, and after touching down, it could right itself, level itself, and take a 360-degree panoramic photo of the landing site and transmit that photo back to the team. This type of mission and the capability is prominently in the minds of scientists and engineers the world over, following the success of the Perseverance rover landing in February of this year. The Experiment Design Award is given to the college or university team with the most creative and innovative way of tackling the challenge while maximizing safety and science and engineering value. For the design division, the winner of the Experimental Design Award is The Ohio State University in Columbus, Ohio. Their design featured innovative locking mechanisms for both retaining the lander prior to deployment and releasing the lander parachute upon touchdown. Perhaps most notable about the Ohio State University's payload documentation, however, was their superbly detailed fabrication and construction plans included in their Flight Readiness Review milestone. Congratulations. For the launch division, in third place, Kent State University of Kent, Ohio. Our second place winner is Vanderbilt University from Nashville, Tennessee. And the first place winner, University of North Carolina, Charlotte, North Carolina. As we saw earlier this year with the Mars Perseverance landing, successful design and performance of payloads requires a team effort. University of North Carolina at Charlotte demonstrated this in every sense of the word. They were one of the only teams able to successfully complete the College Payload Challenge this year. They designed their payload to account for any orientation of landing, and their documentation showcased the landed payload using legs to self-right itself, autonomously leveling itself, and taking the 360-degree panoramic photo. This achievement wouldn't be possible without consideration in design, testing, and implementation. Congratulations.
Whether launching model rockets or big ones like the NASA Space Launch System, everyone wants to know, how high does it go? The NASA Space Launch challenges teams to decide on a target altitude for themselves very early on in the program as part of the preliminary design review package, and then to design their rocket, payload, and propulsion system to meet stringent weight and thrust values in order to achieve that target. Teams use modeling and simulation software to predict their rocket's performance and perform test launches to confirm their models are accurate. The team in each division that comes closest to their prediction wins the altitude award. Often the award is a close competition, sometimes coming down to a single-digit difference between teams and their targets. We're proud to announce the winners. The SLI division this year was a close competition, and the winners are in third place with an altitude difference of 147 feet, Spring Grove Area High School, Spring Grove, Pennsylvania. In second place with a difference of only 30 feet, Nativity Catholic Parish, Burke, Virginia. In space flight, 1 foot can make a big difference. In this competition, the first place team missed their goal altitude by only 14 feet. For this year's SLI Altitude Award, in first place, Sylvania Northwest High School, Sylvania, Ohio. Congratulations. The USLI division was also a close battle, with an altitude difference of 70 feet. Finishing third is the University of Texas at Arlington, Texas. In second place, with an amazing 34 feet difference, is the University of Notre Dame, Indiana. And in the first place, the team missed their target by only 16 feet, a narrow margin from their target of 4,900 feet. The winner of the USLI First Place Altitude Award goes to the University of North Carolina at Charlotte, North Carolina. Congratulations.
Hello, my name is Early McKnight, and I'm honored to represent Bastion Technologies and NASA Student Launch for presentation of the Safety Award. Bastion Technologies is a proud sponsor of this event and shows its commitment to continued support by providing a $500 prize to the first place winner of this award. Rocketry can be dangerous. Working in machine shops and laboratories, launching at the field, testing hardware, even spectating all come with measurable risk. This year, all teams took safety as a priority in their programs, researching, mitigating, and planning for hazardous scenarios. Especially important and very evidently on the minds of the student teams was the precautions necessary resulting from COVID-19 and social distancing. It's obvious every team did an excellent job incorporating safety measures into their operations. The Safety Award is given to the team that has met all of Student Launch's safety expectations and documented it to the highest quality. Here are this year's winners. In third place, the University of North Carolina, Charlotte, in Charlotte, North Carolina. In second place, the University of North Carolina State University in Raleigh, North Carolina. And first place goes to the University of Notre Dame in Indiana. Notre Dame identified and categorized their risks, documenting them in exceptional detail. They managed and mitigated those risks with creative and effective controls. They developed procedures and checklists for tests and launches, implemented team protocols for meetings, laboratory work, and launches, and utilized effective methods to maintain personal health and safety. Congratulations, the University of Notre Dame.
In addition to presenting this year's NASA Student Launch STEM Engagement Award, I also have the honor and privilege of presenting it in honor of a treasured rocketry mentor who passed away earlier this year. After a celebrated service in the United States Navy, Joseph Woodford's involvement in rocketry spanned decades. He served as president and senior advisor for NOVAR and mentored countless students through his work in TARC and NASA Student Launch with Oakton, South Lakes, and Thomas Jefferson High Schools in Northern Virginia. Commander Woodford was laid to rest with full military honors at Arlington National Cemetery. Joe was a good friend and will be greatly missed. It is in his honor that the 2021 NASA Student Launch STEM Engagement Award is presented. Designing rockets and overcoming scientific challenges are, in many ways, the result of a lifetime of learning for the participants of NASA's student launch. That learning, often spurred and nurtured by a parent, teacher, guest speaker, or mentor, is the key to success. That is why we feel it is so important for our student launch teams to follow in kind by reaching out, teaching, and nurturing the next generation of STEM learners. For this year's student launch teams, the challenge was even greater given the unique circumstances that restricted opportunities for in-person learning. Despite these hurdles, teams rose to the challenge and adapted many of their events to a virtual platform. As a result, the student launch teams engaged fellow students and the public with more than 19,000 people at 150 events. It is my honor to recognize the top 3 STEM engagement teams from both our middle high school division and our college university division. In the SLI division, finishing in 3rd place is Sylvania Northview High School, Sylvania, Ohio. Finishing in 2nd place is Harrison Central School District, Harrison, New York. And in 1st place is Oakton High School, Vienna, Virginia. Oakton High School reached over 223 participants in hands-on direct STEM engagement. The team held events with students in grades 5 to adult through the Smithsonian National Air and Space Museum and local schools. The Oakton team lectured and trained fellow students in rocketry, mathematics, and principles. They also included the use of engineering software such as OpenRocket and CAD. This approach allowed students to design, calculate, and simulate flights of their very own rockets. The Oakton team will receive a $1,000 cash prize. Congratulations. And in the USLI division, finishing in 3rd place is University of Notre Dame, Indiana. In 2nd place is Washington University in St. Louis, Missouri. And 1st place in this year's USLI division goes to Vanderbilt University, Nashville, Tennessee. Vanderbilt University conducted STEM activities with elementary, middle, and high school students and educators. Because students could not meet in person, the Vanderbilt team took a hands-on engineering design lifecycle lesson in basic rocketry and adapted it for a virtual classroom. By using their own fabrication facilities, they were able to bring their students' own bottle rocket designs to life, launch them, and virtually discuss feedback with the students about design successes and failures. The team also conducted several events which engaged students in designing rockets and simulating flight in both OpenRocket and MATLAB. The Vanderbilt team will receive a $1,000 cash prize. Congratulations and thank you.
Good afternoon, everyone, and thank you for allowing me to participate today. I am so pleased to join you on behalf of the American Institute of Aeronautics and Astronautics to recognize the hard work of students participating in the NASA Student Launch Project. Personally, this is great fun for me since I had the opportunity through the course of my career to help with the Space Launch System, Orion, the Space Shuttle, and many others during my NASA days. Our Institute's mission is shaping the future of aerospace. Now, I know that can sound like a pretty bold statement, yet AIAA is the world's largest professional aerospace technical society. So we are doing that with the engagement of 30,000 professional and student members, along with 100 corporate members, several of whom are participating in the program today. One of the most important aspects of shaping the future of aerospace is ensuring there is a talented and qualified workforce coming along. We want to see students like all of you develop into the future leaders of the aerospace profession. We want to help you succeed as you move from classroom to career. Please think about joining us on your journey. If you're not already a member, become AIAA student member. Then you have chances to participate in other hands-on competitions such as this, along with connections for your diverse international membership as mentors, opportunities to apply for scholarships, and access to the cutting-edge technical knowledge base of the aeronautics and aerospace industry, which dates back to the early 1900s. The invitation is there for you to join. Now, let's keep this program moving with the presentation of 2 awards, the Vehicle Design Award and the Reusable Launch Vehicle Award. These awards are made possible by the AIAA members who make up AIAA Regions 1, 2, and 5. Designing and developing a rocket is a difficult task in normal years of student launch. This season added the complexities of virtual meetings, limited access to software and simulation systems, and restrictions on testing and construction facilities. All these additional hurdles did not prevent the students from competing in the SLI, and you guys succeeded. The Vehicle Design Award is given to the design division team with the most creative and innovative overall vehicle design that maximizes safety and efficiency. And the winner of the Vehicle Design Award is the University of California, Los Angeles in LA. Congratulations, Bruins. Sponsored by AIAA, this award is accompanied by a $1,000 cash prize. UCLA put an emphasis on structural robustness and stability without sacrificing performance. They meticulously described the assembly from every nut and bolt to every layer of epoxy. From nose cone to fins and liftoff to landing, we congratulate UCLA on a job well done. Now, the Reusable Launch Vehicle Award. NASA Student Launch is all about rocketry, designing, building, and safely flying amateur high-powered rockets. In much the same way, NASA and its partners develop reusable launch vehicles. Competing teams are challenged to design a reusable rocket that can repeatedly fly to predictable altitudes while performing scientific experiments. Throughout the year, each team's design is evaluated by the NASA Review Panel for Safety, Feasibility, and Innovation. This competition builds on NASA's work with the Space Shuttle, the DCX and XA projects that translated into the recent accomplishments of SpaceX and Blue Origin. The AIAA Reusable Launch Vehicle Award is given to the team with the most creative, innovative, and well-constructed overall design while still maximizing safety and efficiency. Here are our winners. In third place, Vanderbilt University, Nashville, Tennessee. In second place, Washington University in St. Louis, Missouri. And in first place, North Carolina State University in Raleigh, North Carolina. NC State's 9-foot and nearly 50-pound launch vehicle performed nominally with respect to their recovery subsystem in their final competition launch. Their vehicle was standard dual deploy with added components for payload jettison and recovery. They implemented an advanced retention and release device, which separated the payload from the main harness. All Nomex sheets and deployment bags used to protect parachutes from thermal conditions during deployment performed well, allowing the launch vehicle to land safely and be reflown with proper preparation. Sponsored by AIAA, this award is accompanied by a $1,000 cash prize. Congratulations.
Good afternoon. I want to thank Dan Dumbacher for taking the time to help present these Student Launch Awards on behalf of AIAA. I must also take a moment to personally recognize a few people that helped make AIAA's participation in this event possible. 3 AIAA regions co-sponsored the awards we are presenting today. Region 1 comprised of the Northeastern United States, Region 5 comprised of the Midwest and Eastern Rocky Mountains, and my own Region 2, which covers the Southeastern U.S. Thank you to my fellow regional directors for co-sponsoring these awards. Finally, I want to thank all the students that participated in our NASA Student Launch Career Expo a few weeks ago. We hope you were able to connect with some enthusiastic aerospace professionals that were excited to talk to you and help develop current students into future aerospace leaders. We look forward to holding similar events for student launch in the coming years. And now it is my distinct pleasure to present the Rookie Award to the most deserving first-year team in the Student Launch Competition. In the NASA Student Launch Competition, an incredible amount of work is expected of competing teams. They must design a high-powered amateur rocket and figure out the best way to tackle the experiment design challenge, all while documenting their efforts in 3 separate milestone review packages. On top of that, each milestone requires teams to present their work to the NASA review panel to ensure that the work is being done safely and to receive approval to proceed to the next milestone. Documentation approaching 1,000 pages in total length and stressful presentations can be a challenge even for the most veteran of teams that have benefit of experience and familiarity with the program. But this rigor and difficulty is amplified for our rookie teams. Our rookie teams in the College and University Division deserve recognition for enduring the rigors of the NASA Student Launch Program, and the most exceptional of those are presented with the Rookie Award. This year's competition had 7 rookie teams. Finishing third is the University of North Dakota, Grand Forks, North Dakota. Our second place rookie team is New York University, New York, New York. And winning the 2021 Student Launch Rookie Award is Washington University in St. Louis, Missouri. Sponsored by AIAA, this year's Rookie Award is accompanied by a $1,000 cash prize. Washington University in St. Louis produced a detailed rocket design with outstanding analysis that included detailed CAD, flight simulations, and calculations. They chose an ambitious approach to the payload lander challenge, proving their determination with a robust testing and verification plan. They did all this while producing professional reports and presentations, staying within a reasonable budget and not losing sight of milestone deadlines. Congratulations.
The Judge's Choice Award is given to the high school or middle school team that has the best combination of documentation, scientific experiment, creativity, vehicle design and construction, and STEM engagement. The winning team is selected by a panel of NASA judges. This year, the continued challenge of COVID-19 made teams find new and innovative ways to complete all of these aspects of the program, especially engaging fellow students and the public in STEM-themed activities and outreach. Despite the added difficulty, all of the teams this year rose to the challenge, and the 3 selected for this award showcase exemplary efforts. Finishing in third place, Whitney Young Magnet High School in Chicago, Illinois. In second place, Harrison Central School District, Harrison, New York. And in first place is Sylvania Northview High School, Sylvania, Ohio. This award comes with a $2,000 prize from the National Space Club Huntsville. Sylvania Northview showed excellence in all aspects of the competition, from their achieved delta altitude of 14 feet to their innovative vehicle and payload designs and their emphasis on public outreach. They designed and built a college payload while engineering a unique recovery system for their launch vehicle. Their STEM engagement activities included a Halloween party with STEM-themed candy and holding launches for students interested in STEM. Congratulations. Congratulations to all of the teams that have won awards here today. Your amazing accomplishments have not gone unnoticed. It's my pleasure to continue to acknowledge the successes of this year's NASA student launch teams by announcing the third place finishing team and presenting the second place winner award in the USLI launch division of this year's NASA student launch. For the launch division, in third place, the University of Notre Dame, Indiana. And our second place winner is Vanderbilt University from Nashville, Tennessee. Vanderbilt will receive a prize award of $2,500. Vanderbilt had a fantastic program this year with strong documentation, a quality rocket design, successful flight and payload operations, and excellent STEM engagement opportunities. Congratulations, Team Vanderbilt.
As a sponsor of the new USLI Design Division, it is a great honor for Northrop Grumman to acknowledge the efforts and accomplishments of teams exceptionally affected by the unique conditions of this competition season. We understand the value of strong design work backed by solid modeling, simulation, and calculations. It is my honor to announce the third place winner and award the second place winner overall in the USLI Design Division. For the Design Division, in third place, The Ohio State University, Columbus, Ohio. And our second place winner and recipient of a prize award of $1,500 is University of California, Los Angeles, California. In the first year of the Design Division, UCLA excelled in all aspects of the competition, from the design, construction, and analysis to even a change in the payload mission. This was evident in their report writing, presentation skills, and attention to detail. Way to go, UCLA, on a job well done.
For the past 9 months, all of the NASA student launch teams have worked tirelessly towards the goal of competing at the highest level. Collectively, thousands of hours were spent designing, simulating, building, testing, and launching rockets and payloads with the goal of scientific and engineering excellence. We are all aware of how exceptionally difficult this season has been, and yet you all rose to the challenge to come to the place you are today. And now, even though we are not able to celebrate together and complete your final launches in Huntsville, we are proud to recognize all of the teams and their many achievements. It is my honor to announce the overall winners of the colleges and universities in both the launch and design divisions of this year's NASA Student Launch Competition. For the launch division, the winner of the 2021 NASA Student Launch USLI Launch Division competition is the University of North Carolina at Charlotte, North Carolina. The 2021 NASA Student Launch winner for the Launch Division will receive a prize award of $5,000. In a year with a lot of uncertainty, one thing remained constant: the University of North Carolina at Charlotte. They showed the importance of teamwork, excelling in all aspects of the student launch competition, including technical writing, presentation skills, public outreach, sufficient testing, and payload and vehicle performance. From being only 16 feet away on their target altitude to successfully completing the College Payload Challenge. This team did it all while connecting with students of all ages to spread their knowledge of STEM and aerospace. Congratulations to the University of North Carolina at Charlotte. And for the Design Division, the winner of the 2021 NASA Student Launch USLI Design Division competition is New York University, New York, New York. The 2021 NASA Student Launch winner for the Design Division will receive a prize award of $2,500. New York University's combination of a complete and detailed rocket design, payload design, and construction and testing plans have proven their team's understanding of rocketry principles and their dedication to succeeding in this competition no matter the situation. Congratulations to New York University, and congratulations to all of the teams for your hard work and perseverance. A job well done.
It is my honor to close out today's ceremony. Several words and phrases have been widely used when describing the past year, such as challenging, uncertain times, and my personal favorite, unprecedented. None of these words are inaccurate, but as I reflect on this year's NASA student launch, I keep coming back to a different word, special. I will remember this year because of what you accomplished. This year's University Payload Challenge was probably the most difficult challenge posed in student launches 21 years. This year was also the first time teams were required to complete the final launch at home. Finding a launch location in the spring when fields are being planted is not easy. Many teams are forced to travel long distances to complete the 3 required full-scale flights. Finally, the brand new Design Division introduced a fresh new milestone, the Payload Modification Vehicle Redesign. The Design Division teams were given a brand new mission and required to adapt their already completed vehicle designs to accommodate the new mission requirements. We threw a lot at you this year, and it was in addition to the other limitations and restrictions you faced due to the unprecedented situation. It wasn't the situation that made this year special, it was you, our 2021 NASA student launch teams. You tackled the demanding tasks and deliverables of this year's challenge with tireless passion, enthusiasm, and endless grit. I hope that student launch is just one of many accomplishments you will have in your lives. As you have proven this year, you are capable of amazing things. Thank you to all of the sponsors who make student launch possible: the Human Exploration and Operations Mission Directorate, NASA's Office of STEM Engagement, Northrop Grumman, the National Space Club, the American Institute of Aeronautics and Astronautics, the National Association of Rocketry, Bastion Technologies, and Bragg Farms. Thank you to the Student Launch Management Team, specifically Allison Chenard, John Eckert, Zach Koch, and Jenny Tan. I appreciate each of you for bringing your A game each and every day. Thank you to today's speakers and presenters for helping us to recognize the remarkable accomplishments of our teams. But finally, a big thank you to all of the teams for your participation in student launch. To those who are graduating, I'd like to wish you the best of luck as you move into the next phase of your lives. To the undergraduates, we hope to see you in the fall. Congratulations, everyone, on completing the 2021 NASA student launch.